Hello and welcome back to Steve and Steve. Today we're going to go through binary division. So this is going to carry on from what we've done already with binary addition, subtraction, and multiplication. Now, the first question you may be asking when we get into binary division is, what do we do? Right? So it's exactly the same as what we do when we do normal division. So if we had 5 and 26, how many 5's going to 26 is 5, and then there's a remainder 1. And then we're going to follow this particular process, which we're going to go into a bit more detail. But if we look here, there's 5, 101, and this number's 26. Here's the other 5, and then there's the remainder. So we're going to follow this process in the middle here, and hopefully it's going to make more sense by the end of this presentation. So first question is, why do we need binary division in our lives? So it's actually really useful for encryption algorithms. So when we're transferring information, the divisor that we can use is actually known as a cipher or a key, and that changes the way that the text comes out. So basically, you would divide to get the encrypted text, and then what happens is you times it at the end, and you get back the original information. So it's super useful basically for encrypting text. So first question is, how do we divide them? When dividing, you're basically breaking up into groups of the divisor. So for example, if we do 12 divided by 2, that's the same as if we had 12 Ninja Turtles and we broke them up into groups of 2, right? We're breaking them up into the parts or sharing them out appropriately so they're equally balanced. So then that's why that is equal to 6. So we actually have 6 groups of 2 Ninja Turtles. Okay, so this is an important concept of why dividing works. So how do we long divide then? Okay, we're just going to follow a simple process and then I'll get you to have a crack at this yourself. First step is know your divisor times tables. So we're dividing by 5 in this time. So you can either write them out or know them back to front. Okay, so I've written a little table up here in the top left. So 0, 5, 10, 15, 20, etc. And the next step then is you want to divide into the single number to the next of it, right? So straight into this number here, you always start from the left and work your way across the right. Okay, so in this case, how many 5's going to 6? That's pretty easy. That's 5. So 6 is between 5 and 10, so you go to the number below it. So that's 5. One lot of 5 is then what goes down. So then you write the number above the line. You then take away the multiplied answer. So 1 times 5 is 5. We subtract that. So 6 take away 5 leaves us with 1. We then bring down the number to the right of it. So that 7 then floats on the way down. And then we just repeat that process until we get to this end. Okay, so hopefully that process just makes it a little bit clearer. So instead of how many 5's going to 67, we can't do that because we've already got the 6 and we've worked that out. It was one lot. We now go down to this number here in the yellow, red and green. So how many 5's go into 17? So again, we go back up to our trusty little table here. 17 is between 15 and 20, so it's actually 15. So then how many 5's go into that is just 3. So you put a 3 up the top there. You then do your 5 times tables with 3. So 5 times 3 is 15. So we write the 15 underneath. We then subtract it. So 17 take away 5 leaves us with a 2. We then drag down that 2. So that 2 should float all the way down to the bottom there. And we go again. So then how many 5's go into this new number 22? We go to our trusty table. So it's between 20 and 25. So it's 20. So that's 5 times 4. So we put a 4 up the top here. 5 times 4 is 20. We write that down the bottom here. So just subtract it. Now we go through the same process and hopefully you've picked up the algorithm here now. So 22 take away 20 leaves us with a 2. We then drag down that 5, right? And then we go here. 5 times 5 is exactly 25. So we're set. So we put a 5 up the top there. 5 times 5 is 25. 25 take away 25 leaves us with a 0. So how many 5's go into 6,725? You would actually have 1,345 groups of 5 if we split them up, like that Ninja Turtle example we gave before. So this time I want you to actually try and apply this yourself. Have a go at this one and follow exactly the same process that I just did in the previous video. So just pause the video there and we'll come back soon. Hopefully you've paused that video. Great. Awesome. Welcome back. So the first process, know your divisor times table. So we're dividing by 3. So here's our divisor times tables: 0, 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. So then the first step is how many 3's go into 1? Not possible. So we extend that number out. So we just go to the right. So instead of having to draw it all the way down, because we're starting at the beginning, you just go to the right. How many 3's go into 10? So 10's between 9 and 12. So we go to the 9. So 3 times 3 is 9. So we'll write a 3 up the top there. Follow the process. 3 times 3 is 9. We write that underneath it. We subtract it. 10 take away 9 leaves us with a 1. We then go to the column next to it with the 4. That then floats on down to the bottom. We look for where 14 belongs. So 14 is between 15 and 12. So how many 3's go into that is 4. Right? And then 3 times 4 is 12. 14 take away 12 leaves us with a 2. We then go to the column next to it with the 4. That floats on the way down. So how many 3's go into 24 is 8. 3 times 8 then gives us a 24. Subtract that and we're left with a 0. Fantastic. So going back to that, just so you can see it, how many 3's go into 1044 is 348. Okay. One last go at trying to do this by yourself, and then we'll move on to the binary division. So hopefully you've mastered most of that skill. If not, just have a go with this one again, okay? So this one's a little bit easier. We're going to divide by 2. And it's how many 2's go into 7,134. So just pause the video there, and we'll play it, go through it soon. Okay, welcome back. So here we go. First step, we know our divisor times tables, so we write them all out. So we got 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Now, I'm purposely going through all these to show you that it's a very long, tedious process of running out all your times tables when we use a decimal system. When we get to binary, it's actually a little bit easier. Okay. So you know your divisor times tables. Okay. You then divide it into a single number. So how many 2's go into 7? So 7's down here. So 6 and 8. So it's 3. So 2 times 3 is 6. So we write the 6 underneath it. So then it's 7 take away 6, which leaves us with a 1. We then go across the column to the right. We bring that down. And we repeat the pattern. So then when we bring the 1 down, how many 2's go into 11 is 5. 2 times 5 is 10. So then 11 take away 10 leaves us with a 1. We then go to the column across to it. We've got a 3. We bring that guy down. How many 13? So let's have a look. 13 is between 14 and 12. So it's a 6. 6 times 2 is 12. 13 take away 12 leaves us with a 1. We then go to the next column across, the 4. We bring that guy down. So we've got 14. 14 goes into it perfectly. So we've got a 7. And we're all good. So then we've got 14 take away 14. And we're left with our 0. Awesome. Cool. Excellent. So moving on. This is when we move into the binary numbers. Okay, so it's a little bit different, but it's exactly the same process we've just done. Okay, our number system's a little bit simpler though, so that's what we need to focus on. So the first thing is we've got 101 going to 101101. Right. So the first step, how many 101s or 5s go into 1? Well, can't do it. Can't go into 0. And then can it go into the next one across? So the first step is we need to know all our divisor times tables with this. And it's really, really simple. Okay? That's it. You're either timesing it by 0 or timesing it by 1. So if you're timesing it by 0, you can't do it. If you're timesing it by 1, you can do it. Okay? So the cool part with this is you're either able to divide by it or you can't divide by it. So move on. Okay? So how many 101s go into the 1? We can't do. We can't do the 0, but we can do 101 into 101. Right? So 101 into 101 is just 1 because you got one lot of that. We then do 1 times 101 underneath it. And then we just subtract it. Now, we could use 1's complement, 2's complement, all that. I'm happy when you're doing this version of subtraction just to follow the pattern. So 1 take away 1 is 0. And then you could borrow the columns as well if you wish. Right. So then we bring down the 1. How many 101s go into just 1? Well, there's none. We then go to the next column. We bring down the 0. How many 101s go into 0? Well, again, Can't do it. Then we bring down the next column. We've got a 1. How many 101s go into that? Is just 1. So this is 5. 1001 is 9. So 5 9s or 45. So we've got, what's this number here? A 1, a 4, so we're up to 5, an 8, and then a 16. No, 32. 8 and a 32. So 32 plus 8 is 40. 4 plus 1 is 5, so we've got 45. So 5 divided by 45, is it equal to 9? Absolutely. Okay. So we subtract that, left with nothing over. And then we check it. 45 divided by 5 is equal to 9. Yep, absolutely. So you should be able to always check these answers when you get to the end. So the next one, a little bit trickier. So I've done 110 into 101 1010. Okay. So you can either pause the video and have a crack yourself, or you can follow along as I go. Okay, so this one's a little bit trickier, so it's not going to be as cookie cutter to fill in the blanks. But let's just start again. So first of all, we write out divisor times tables. So you're either times it by 0 or times it by 1. So either you don't have it or you do. And then we just look at the columns. So how many of those go into 1? We can't do. We can't go into 0. And then if we go 101, basically this is 6 because it's 4 plus 1, 2. So how many 6s go into 5? That's not possible, is it? So what we actually have to do is go to this fourth column. So it's how many 6s, and it's 1 0 1 1. So that would be, what is it? 1 plus 2 is 3 plus 8, so it's 11. So how many 6s go into 11? Now we should be able to understand that's going to have a remainder, isn't it? So it's going to have one of them, and then it's going to have a little bit left over. So this is where it gets a little bit trickier. We actually have to do subtraction as we go. So in this case, there's one lot of 110 that goes into this. Okay, so we write the 1 up the top there, and then we just go through and do our times tables. So 1 times 110 goes underneath it, and then we subtract it. Okay, now this is where it's a little bit trickier. Okay, 1 take away 0 still leaves you with just 1. 1 take away 1 leaves you with 0, and then 10 take away 1 leaves you with a 1. That should be okay. Yeah. Which 101? Oh, 11 take away 6, does it equal 5? Absolutely. So we've still got the same numbers. Okay. We can't divide that into 5 again, can we? So what we have to do is bring down the 0 again. So we bring that 0 down here. How many 110s go into this one? Well, it definitely does go into it. So there's one lot of them because it's bigger than that. So we've got 1 and a 1. So that's 8 plus 2, which is 10. So how many 5s go into 10? Oh, sorry, 6s. How many 6s go into 10? Otherwise that wouldn't have worked. Right, so we've got to do this again. So now we've done 1 times 110 here. We're going to subtract it. So 0 to take away 0 gives you 0. Right? 1 take away 1 leaves you with 1. And then the 0 on the end. We then bring down the 1. How many 110s go into this one? So what we have is we've got a bigger number than 6 because we've got 8 plus 1, which is 9. So that definitely will go into it. So we put a 1 up the top there. 1 times 110 goes down the bottom here, and then we subtract it. So 1 take away 0 leaves you for 1. This is where it gets a little bit trickier. So we can't subtract that, so we must borrow from this column. So we're left with a 1 there. So 10, instead of 10, becomes a 1, because 2 and then 1. And then we bring the 10 across here. 10 take away 1 leaves you with just 1. And then 1 take away 1 is 0. We then bring down the zeros column. And then how many 110s go into that? Perfect. We've got exactly the same, the identity, don't we? We've got one lot of it. So we take away one lot of it, and we're left with our 0. So now we get 1111, which is 15, and then 110. So we've got 15 and 6. So 90, which is what this number works out to be, divided by 6, does it equal 15? Absolutely. Perfect. So your turn. Have a go at it. So I'm going to give you this number and use the same pattern that we just did. So remember, write out your times tables, and then just follow the process. How many groups of the divisor goes into that particular number up to where you're at? Do it. Write the times table underneath it, subtracting it, and then just follow the pattern. So you're either subtracting 101 or you're not subtracting 101. That's the thing that you need to think about. So I'll pause the video there and we'll go through it soon. Okay, welcome back. So we've got 101 into this number. So it can't go into 1, it can't go into 10, can't go into 100, but it can go into 1,000. So we're up to the 4th column across. So the first step is we write our divisor times tables, which again should be super easy. Sorry, that should say 101. I'll change that later. Actually, we'll change it now. There we go. Don't look. Awesome. So 101, how many lots of those go into it? So it goes 1 lot of it. Okay, and then if it's not possible, you basically write the numbers underneath it. So 1 lot of 101, you go 101. We then subtract it. We've got to borrow all the way from that left-hand column. So again, you don't need to use 2's complement with this. You can cheat, okay? You have my permission to do it with these ones. So we're going to borrow from the 1. So we cross that out. That becomes a 1. That crosses out and becomes a 1. And then you're left with 2 on the top, right? So it's the same as if you're taking 9 from the 1 from the thousands column, and then you cross it out and it just becomes a 9 up the top. Okay, so I haven't written 10 there because what happens is I have 10, I'm crossing that out, and then it carries across to become a 10 there. So then 10 take away 1 leaves you then just with 1. 1 take away 0 leaves you with 1, and then 1 take away 1 leaves you with nothing. We then go to the column next to it. We borrow it down, so the 0 will float down. How many 101s go into that is 1. So we write 101 there. We then follow the pattern. So 0 take away 1 we can't do, so we must borrow from the column next to it. So that becomes a 10. 10 take away 1 comes down, becomes 1. 0 take away 0 leaves you with 0. And then 1 take away 1 leaves you with 0. We then go to the column next to it, bring down the 0. So can we divide 101 into 10? Nope. So then we go to the next column. So we put a 0 up here, bring down the next column, which is a 1. And then how many 101s go into that is 1. Cool. So then 101 take away 101 leaves us with a good old 0. We check. So this number here is 65 divided by 5. Does it equal 13? And yes, it does. Awesome. So that's pretty much all that I wanted to go through with the core skills. My hint to you is to practice a couple times. You can always check if your answers are right. That's the really cool part with this when you're learning divide. Okay, so just convert it back into the decimal numbers, even if you need to use a calculator just so that you can quickly see if you've got the right answer, is what I would recommend to do. So hopefully you've learned something about binary division in this. And if you have any questions, just pop them in the comments. More than happy to go through it. Awesome. Thank you very much. And see you next time on Steam It with Steve. Adios.